Hello, welcome to today's video on section 2.7. Section 2.7 is about using absolute value functions and transformations. So we're going to start with a simple example. The first example will be the graph y equals the absolute value of x. So we've talked about absolute value before. We know what absolute value does. It makes anything negative to positive, and anything that's positive stays positive. So usually when we graph something for the first time, it might help for us to make a table. So I plug in maybe a few values for x, like when x is 0, y is 0, x is 1, y is 1, x is negative 1, y is still 1. Maybe a couple more, x is 2, y is 2, x is negative 2, y is still 2. Make a coordinate plane. 1, 2, 1, 2, 1, 2, 1, 2. Plot our points. It's got 0, 0, 1, 1, 2, 2. And what will happen is that when we graph the absolute value function, it's actually going to take on the shape of a V. It's kind of like a parabola, but not curved. You have straight edges. So that's basically how absolute value function will look. We also call this the parent function because it's the most basic function for this type of graph. We also call the sharp corner the vertex. The vertex is at 0, 0 for obvious reasons. So these are some things you want to keep in mind. So let's try another example. Let's switch things up just a little bit. So number 2. Let's graph y equals the absolute value of x plus 2. So before we begin making our table, let's think about what is going to happen to the graph if we consider the first graph, y equals absolute value of x. What's going to happen to it when we add a 2 to the outside? Well, if we make a table and plug in the same values as before, now when I plug in 0 for x, y is 2. When I plug in 1 for x, y is 3. Negative 1, still going to be 3, because remember the absolute value of negative 1 is 1. Plug in 2, I get 4. Negative 2, I also get 4. So when you graph this, 1, 2, 3, 4, 1, 2, 1, 2. Plot the points. So you see it still takes on the shape of a V, but it's pretty obvious that the graph shifted up by 2. So in this case, when we talk about transformations, think about what transform means. Transform means changes. So we look at the transformations, you have shift up by 2. And I will ask you to state transformations when you do the classwork next time we meet. And you're saying the transformations from y equals absolute value of x. So shift up by 2 from y equals absolute value of x. Let's look at another kind of change. Let's say I did something like this here. So say I add 2 inside the absolute value. Now this is going to be a bit weird and not as intuitive. Hopefully number 2 is somewhat intuitive. If you add 2 to the outside, it goes up 2. And by the way, if I were to subtract 2 to the outside, going back to number 2, if I had absolute value of x minus 2, then it would have gone down by 2 units. But what if I do something like this? What if I do something inside the absolute value? Well, if I plug in 0, I get 2. Plug in 1, I get 3. But if I plug in negative 1, now I get 1. Plug in 2, I get 4. But plug in negative 2, I get 0. Let's plot these points and see how it looks. So 1, 2, 3, 4. 1, 2, 1, 2. Okay, 0, 2, 1, 3, 2, 4. Then negative 1, 1, and negative 2, 0. So you can see right now I don't really have the shape of a V. I just have 5 dots that all can fit on a line. But what if I decide to test a few more x values? Like what if I tested negative 3 or negative 4? Now when I plug in negative 3, I get 1 for y and 2 for y. So when I plot those points, you will see that we actually do get a V. But the only difference when we look at the transformations okay, that was horrible. I could do better than that. Okay. Transformations. It's going to shift to left from y equals absolute value of x. So if we look from before, the vertex is at 0, 0. Here our vertex is at 0, 2. And now our vertex is at negative 2, 0. So this leads me to a general equation that we can state for absolute value. This is a general or a standard equation for absolute value. And here's how it goes. So there's some new variables here. H will represent the horizontal shift, or it could also represent the x coordinate of the vertex. K will represent the vertical shift, or the y coordinate of the vertex. So if we think about it, here we have x plus 2. If you x minus negative 2, because we assume the form x minus h, if I plug in negative 2 in place of h, x minus negative 2 becomes x plus 2. So the plus 2 actually causes the graph to go to the left by 2. Whereas here, you see plus 2 and you see nothing inside the absolute value connected to x. So h is 0, but k is 2. So we see a vertex of 0, 2. But again, our h here was negative 2, and our k was 0, so only went to the left by 2 units. The a will affect the vertical stretch. So we call it the vertical stretch factor. Can also cause the graph to reflect. That's another thing to keep in mind. So let's do one more complicated problem, and then we'll end the video. So this is our fourth graph for today. So our fourth graph for today will be the following. Y equals, say we got negative absolute of x minus 1 minus 3. So without making a table, I know that h is 1 and k is negative 3 because I'm simply comparing it to the general standard equation. What's in place of h here? X minus h, x minus 1, h has to be 1. What's on the outside? Minus 3, so k is negative 3. And of course a is negative 1. So what I can do when I graph this is I can locate my vertex. So 1, 2, 1, 2, 1, 2, 3, 4, 2, 3, 4. So it's at negative 1, negative 3. And since a is negative, the graph will be upside down. And how I know that, what if I plug in two x values that are close to negative 1, like negative 2 and 0? If I were to work it out, I would get negative 4 in each case. And so the graph would look like this. Now, what if a were 2 or 3 or 4 or 1/2 or 1/3? We'll actually discuss that in class because I don't want to overwhelm you with too much information in this video. There's also going to be another thing we're going to talk about in class next time we meet. This is part of the extension of 2.7, and that's called piecewise functions. From my experience from last year when I tried to put this in a video, it was a little bit too complicated. So I figure just focus on this, take notes on it. I'll ask you some questions about it in the Google form that you can find the link for on our agenda. And when we meet as a class, we'll make sure everyone's okay with everything that's on the video. We'll do a more complicated absolute value graph, and then we'll talk about piecewise functions and how it relates to absolute value. So do expect somewhat of a lecture the next time we meet, and then of course then there'll be some practice problems that follow when we meet again as a class. All right, well, have a great weekend. And lastly, go Giants. All right, have a great weekend.